Today we are going to look into inequalities. Take a couple minutes to write down your vocabulary. We will cover three different types. First one is simple graphing. Second one is solve then graph. Third one is multiplying or dividing by a negative. In order to solve inequalities, we are going to follow the same steps we have done for the equations. We will use inverse operations, DC-VAM, to isolate the variable. We just need to make sure that whenever we are multiplying or dividing both sides of the inequality by a negative number, we will flip the direction of the inequality. Whenever we are graphing, we will decide whether our starting point is going to be an open circle or a closed circle, and we are going to draw an arrow to the direction of the solutions. Here's our first example. We are going to solve this inequality just like we solve equations. We're going to add 3 on both sides. These are going to add up to 0. 2x is less than or equal to 6. Divide each side by 2. These are going to divide to be 1. 1 times x is less than or equal to 3. Let's say 0 is here, 3 is somewhere around here. Our solutions are going to include 3, and x values are less than 3. So I consider the values that are less than 3 into my solution. Now the check step for inequalities has 2 levels. One of them is going to tell us whether our point 3 was correct or not, and the other one is going to tell us whether the direction is correct or not. At first, let's confirm whether our point 3, critical point 3, was the correct answer or not. We will write it as if it was an equation, and we will substitute the value we found. 2 times 3 minus 3, is it going to be equal to 3? Then 6 minus 3, is it going to be equal to 3? 3 is yes, equal to 3. This equality shows that our point x starting from 3 was a correct point. Now, how do we know whether we draw the arrow to the right direction? To check that, we will select any x value from the direction. I usually try to select easy points such as 0, 1, 2, and so forth. In this case, I'm going to select an easy point, 0. Let's say that 0 is an answer. So when you put 0 onto the inequality itself, 0 must satisfy the inequality. This is our inequality. I will substitute x is equal to 0, and because all the x's that are less than 3 are solutions, when I select any x that is less than 3, in this case I'm selecting 0, when evaluated, that should give us a true result. 2 times 0 is 0 minus 3, is it less than or equal to 3? Negative 3 is yes, it is indeed less than or equal to 3. So this true statement tells us that our direction was also correct. That's how we can check the inequalities. I know the check steps are doubling the amount of work. You should use the check steps whenever you are not sure about your solutions, but try to use them as often as possible. Here's our next example. We will undo the subtraction 6 by adding 6 on each side. These add up to 0. 3z is greater than 27. Divide each side by 3. Divide each side by 3. These divide to 1. 1 times z is greater than 9. Let's say 0 is here, 9 is somewhere in here. Z values are going to be greater than 9, and 9 is not included, so we will take the numbers that are more than 9 and we will put our direction accordingly. And I will do a check step at 2 levels again. First one was 3z minus 6 is equal to 21. That's going to tell us whether 9 was the correct point. I will substitute 9 in here and then see if it's going to be equal. 3 times 9 minus 6, is it equal to 21? 27 minus 6, is it equal to 21? 21 is yes, equal to 21. Let's do the second level of check step, which is going to tell us whether our direction was correct or not. According to our direction, if we choose a number that is greater than 9, that number should be in our solution set. So I'm going to choose an easy number. I'm going to select 10. And 10 should give us a true result in our inequality. Our inequality was 3z minus 6 greater than 21. When I substitute 10 instead of z, I should get a true result. 3 times 10 minus 6 greater than 21. Is it greater than 21? That's what we are checking. 30 minus 6, is it greater than 21? And 24 turns out to be yes, greater than 21. This is a true statement, which is confirming that our direction was also true. Now, let's write an interval for this one as well. To write our intervals, we are going to look at what is the least value and what's the maximum value for our solutions. Our least value for solutions is going to be 9. However, 9 is not included. Not included is a regular parenthesis. Our maximum value is going to be infinity, positive infinity, and infinity is not a defined number, therefore it's never included. It will always have a parenthesis. Here is your first you try. Isolate the variable, graph your solutions, and state the interval. Second you try. Here is our next type. Solving inequalities involving multiplying or dividing by a negative number is going to require us to change the direction of the inequality. Let's look at this first example. Let me change this number to 17 so it will turn out nicer. This is a positive 2. I will subtract 2 from each side of the inequality. We will have negative 3y is greater than 15. We will divide each side by the inequality with a negative 3. Negative divided by negative, positive 1. 1 times y is y. Because we divided the inequality by a negative number, we need to change the direction of the inequality. Positive 15 divided by negative 3 is negative 5. Let's say 0 is here. Y values are going to be less than negative 5. Negative 5 is going to be a number somewhere around here. And y values are not included, open circle. Less than negative 5 is going to go towards the left. I can do my check step to confirm my point was correct. 2 minus 3y, is it equal to 17 by, then we substitute negative 5 for y value. 2 minus 3 times negative 5, is it equal to 17? 2 plus 15, is it equal to 17? 17 is yes, equal to 17. This true result confirms that negative 5 was the point that we were looking for. Now let's look at this, see if our direction was correct. For our direction, we need to choose a value that is in the solution set. I will select an easy value here, let's say negative 10. On my check step, I will do 2 minus 3y is greater than 17, and I want to see if I put negative 10, is it going to be true? 2 minus 3 times negative 10, is it greater than 17? 2 plus 30, is it greater than 17? 32 is indeed greater than 17. This is a true result, which confirms that our direction was also correct. Let's write the interval for this one. The least x value we can, the least y value we can consider is negative infinity. The biggest maximum y value we can consider is negative 5. Negative 5 is not included into our solution. Infinity is never included in our solution. Here's your u-try. Make sure to change your direction when you divide each side by the negative number. Here are a couple more examples. On these, we are going to look at the graph. From the graph, we are going to write the inequality and the interval that goes with it. On the first graph, it looks like our x values are starting from negative 6 and going towards positive, increasing from negative 6 and going higher and higher. So x values looks like all the numbers that are more than negative 6. And because negative 6 is included, we are going to have x is greater than or equal to negative 6 as the inequality. For the interval, we are going to consider what is the minimum x value and what's the maximum x value. Minimum x value is negative 6. Maximum x value is positive infinity. Is negative 6 included? Yes. So we use a square bracket. Infinity is never included. Regular parenthesis. Here is the second example on this page. Our inequality starts from negative 1 and goes towards the negatives. And its x values are getting lower and lower. So all the x values are lower than negative 1. So I will put x is less than negative 1. Because it was an open circle, I just use less than sign. Interval for this one, again, we are going to look at the least value and the maximum value that x can take. Least value is going to be negative infinity. The maximum value is negative 1. Negative infinity is never included, and because it's open circle, negative 1 is also not included. Therefore, we use a regular parenthesis. Here is your fourth u-try. And your last u-try. That's pretty much it. If you have any questions, please make sure to bring them in the class.